I wonder what's on the news tonight.
Hello everyone, and thank you for tuning back into Channel 8. I'm your host, Tao Huynh.
And I'm Caitlin Tan. Today we welcome you back with a special guest from Cheatham, Manchester, and his assistant here to talk to you about his new discovery.
So today we have a special guest, J.J. Thompson, and his assistant coming in, and they both had a lot to do with the periodic law, which is when elements are arranged in increasing atomic number, their periodic pattern is shown in their physical and chemical properties.
The topics they'll be covering are the periodicity patterns and trends, such as atomic radius, ionic radius, ionization energy, and electronegativity.
For a little bit of background for the viewers who don't know much about chemistry, the periodic table is organized by groups and periods, and groups are the columns and the periods are the rows. So some of the similarities between the elements within the same group are that they all have the same number of valence electrons, and the elements within the same period have the same number of outer shells. Mr. Thompson, thank you for joining us today.
No, thank you. It is such an honor to be presenting my work onto your platform.
So you discovered the first subatomic particle called the electron using the cathode ray tube experiment in 1904.
Yes, the experiment showed that gases discharged electrical light energy particles, and I saw that particles deflected towards the positive side of the tube, meaning the atoms contained a negative subatomic particle.
Wow, fascinating. And you also developed a model of the atom? Can you explain what it is and how it relates to the periodicity of elements?
So, atoms of a particular element contain a specific number of electrons arranged in concentric rings that tell us the property of elements and how they repeat in a pattern based on their position on the periodic table.
There are four trends that pertain to periodicity. They are ionic radius, atomic radius, ionization energy, and electronegativity. Atomic radius is how large each atom of an element is.
And how do the trends of atomic radius work going across the period?
The atoms get smaller going from left to right because of the increase in nuclear charge, meaning the electrons are getting pulled towards the nucleus.
How's it different from going down a period?
Atoms get larger as you go down a group because the atom is occupying more energy levels, so the outer electrons are pushed farther away from the nucleus.
Why are chemists so great at solving problems? Because they have all the solutions.
Ionic radius is how big the ion in the element is. In this trend, the closer the element is to the bottom left corner of the periodic table, the higher the ionic radius is. For example, with chromium and gallium, chromium would have the larger ionic radius due to its position on the periodic table.
Another trend on the periodic table is ionization energy. Ionization energy is the amount of energy required to remove an electron from the outer shell. Ionization energy is similar to electronegativity. For ionization energy, the energy increases as the element gets closer to the upper right corner of the periodic table.
The reasoning behind this is because the ability to lose an electron from a full energy shell requires much more energy due to the tendency to have a full valence electron shell. Also, as the period increases, so does shielding. Therefore, the attraction between the positively charged nucleus and the negatively charged electrons are weaker, making it easier to remove the electron.
Dr. Thompson, you were talking about the similar qualities of the ionization energy trend with the electronegativity trend. Can you go more in depth about electronegativity?
Why yes, electronegativity is the ability to gain an electron. As I described before about ionization trends, the energy increases as elements get closer to the right corner of the periodic table. Instead of the amount of energy it takes to remove an electron, it's the amount of energy it requires to gain an electron. Easy as is.
Thank you. Next.
In 1869, I published all 60 elements structured by an increasing atomic mass and grouped elements together with similar properties. My good friend Henry Moseley refined my periodic table to look more organized. Tell us about it, Moseley.
Oh yes, Mendeleev, I found that organizing the elements by atomic mass was way too unorganized, so I rearranged the elements by atomic number, or the number of protons in each element.
All by using X-rays? What a genius! I would tell you a good chemistry joke, but all the good ones are gone.
Sorry to say, but these chemistry jokes are getting a bit boring. Thanks for tuning in and see you tomorrow.
Wonder what game shows are on.
Welcome back to Family Food. I'm your host, Steve Harvey, and we have 8 families here today for y'all. We're gonna shake things up a bit. We're going to be using the category of chemistry. Drum roll, please. Periodicity. Tonight we have the alkali metals, the alkaline earth metals, the transition metals, the inner transition metals, the boron family, the carbon family, the nitrogen family, the oxygen family, the halogens, and finally, the noble gases. And the winners of tonight's show will walk out of here with $20,000. Okay, what's the properties of alkali metals?
They're very reactive metallic elements. Go.
Correct. What is the electron configuration of the alkaline earth metals, and how many valence electrons do they have?
-4, they have 4 valence electrons.
That is incorrect. On to the next family.
Hi, I'm the carbon family.
I'm the boron family.
I'm the inner transition metal family.
What group are transition metals a part of, and what is the name of this block?
Groups 3 to 12, and this is called the D block.
Correct. What block are the inner transition metals found in?
F block.
Correct. What is the electron configuration of elements in the boron family, and how many valence electrons are in the outermost shell?
NS2, NP1, and they have 3 valence electrons.
Correct. Get these last 2 questions right, and you are going home with $20,000. What are the properties of halogens, and why are they so?
They're highly reactive nonmetals because they have 7 valence electrons, which cause them to gain another electron very quickly.
Correct.
Easily.
Last question. Explain the properties of noble gases and give at least 2 examples.
They are gaseous and non-reactive nonmetals because they have a full shell of 8 valence electrons. 2 examples are helium and neon.
I think I'm done for today.